Hello. Hello. We will discuss Boolean Algebra in the subject Fundamentals of Computers. The Boolean Algebra is a mathematical system for the manipulation of variables that can have one of the two values. Those two values in the formal logic are true and false. In the digital systems, these two values can be on, off, or 1 and 0, or high and low. The Boolean expressions can be created by using the Boolean variables and the operators. Like the mathematical expression will have the mathematical variables and the operators. Boolean expressions will have the Boolean variables and the operators. The commonly used operators in Boolean algebra are and, or, and not. We will now study about these common operators. Coming to the Boolean AND operator, the description of the truth table of AND is given in the table shown on the right side. X and Y. Because the input variables take the values either 0 or 1 in the digital logic, or it can be true or false. 0 is nothing but false, 1 is nothing but true. X and Y. X can take the value 0 or 1, Y 0 and 1. Because there are two values 0 and 1 applied on the two variables x, y, there can be combination of 4 different possibilities on x and y. So here we have 0 0 0 1 1 0 1 1 and operation on the input values 0 0, that is the output x and y. There can be a dot between x and y, or even if we don't keep, that is taken as AND operation on the input values x, y. 0 and 0 gives 0, 0 and 1 gives 0 as the output, 1 and 0 gives 0 as the output, 1 and 1 only gives the output as 1. So here in the AND, if any one of the input values is 0, the output will be 0. If all the input values are true, then the output will be true. True is nothing but 1 here. And the truth table for the OR operator is given below. Similarly, x, y will have 4 different combinations of input values. 0 or 0, OR is given with plus operator. 0 or 0 gives 0, 0 or 1 gives 1, 1 or 0 gives 1, 1 or 1 gives the output as 1. OR says that if all the input values are false, then the output will be false. If any one of the inputs is true, the output will be true. So that is the reason why all the values, the 3 values in the input side are true, whereas only one, that is all input values 0 combination is 0 in the output side. And the gates, coming to the logic gates, the representation of this AND OR is given here. AND is the first figure, and the OR gate, we say these as the logic gates. AND gate, where A, B are the inputs and it is giving Y as the output, that is A and B is equal to, is nothing but Y. Similarly, in the next figure, OR gate is taking the inputs as A, B, and Y is nothing but A plus B or A or B. And coming to the next common operator in Boolean algebra, that is NOT. The truth table for NOT is, if the input value is 0, output will be 1. It can be represented with x complement, a bar on x, or x dash we can write, or negation symbol x we can write. Input value 0 gives the output x complement as 1. Input value 1 gives the output as the negation of it, that is 0. And the symbol, the logic gate for this is given as shown in the figure. A is the input given, and there is a bubble to the triangle which says that Y is A complement. And here a Boolean function will have at least one Boolean variable, at least one Boolean operator, or at least one input from the set 0 or 1. Boolean function is nothing but here the Boolean expression, and it will give the output which is the member of 0 or 1. So let us see some examples in the Boolean function. F of x comma y comma z is a Boolean function which is nothing but x z complement plus y. This is the example given. We will write the truth table for this Boolean function. Because there are three input variables in the function x, y, z, on the truth table, right side given in the table, there are 2 power 3 combinations. 2 power n different combinations will be there in the truth table where n is the number of the input variables. Because there are 3 variables here, 2 power 3, that is nothing but 8 combinations will be there in the truth table. And coming to the expression side, because we have to find x z complement or with y. So z complement is given on the next block of the table. Z complement is nothing but whatever values in z column are there, those are reversed here. 0 is complemented to 1, 1 is complemented to 0. And because x and z complement is there in the expression, we will find xz complement. That is nothing but see the column x and see the column z complement and do the AND operation on both of these columns. 0 and 1, if any one of the inputs is 0, the output will be 0 in AND operation. So that is the reason why the first value in xz complement is 0. The next value 0 and 0 is, obviously it is 0. 0 and 1 again is 0. 0 and 0 is 0. 1 and 1 is nothing but 1. So similarly, fill the remaining values in the column. And the final expression is xz complement or y. So now xz complement, do the OR operation on the y column. So that is nothing but the third block in the table. So this is how we write the truth table for the Boolean functions. So next class we will see how to minimize the Boolean expressions. Here the Boolean expressions can be minimized using Boolean laws and coordinate maps. First we will study about the Boolean laws and then try to minimize the Boolean expressions using Boolean laws. Then we will see the next method of minimization, that is using coordinate maps. Thank you for today.